Hello everyone, my name is Bhagesh Kolekar. I'm a final year electronics engineering student at the University of Mumbai. This presentation is on my microwave oven project, which I designed during my internship at Emersi Information Technologies. To get started with the internship, we learned about the introduction to C programming language, wherein which we got familiarized with concepts such as statements, loops, operators, types of arrays and pointers. Later on, moving ahead, we learned about different functions and strings. In the initial weeks, we also learned about embedded systems, the differences between microprocessors and microcontrollers, and so on. Moving ahead with the project, we use the MPLAB IDE in order to code the project. We use the XCV compiler in order to compile the entire project, and we use the PiximLab software in order to view the output of the project. For this entire internship, we were focused on the microcontroller from the PIC family, which is nothing but PIC16F877A. Moving ahead in the presentation, we about the various integral components that would be required in order to build a successful project. Firstly, getting started with the functionality of a microwave oven. Then secondly would be the resources required in order to execute the entire project. Thirdly would be the understanding and the architecture of the microcontroller that we'll be using, that is from PIC family. Fourth, we learned about matrix keypad, which was integral in getting the user input. Fifth, we moved on to crystal LCD display, which was used to take the information and deliver it to the user. And we also learned about the concept of interrupts and the ISRs associated with the same. So what is a microwave oven? So microwave oven is nothing but an electronic appliance which is used to heat and cook food by exposing microwave frequency range. This range varies from 200 to 300 nanometers. It uses the principle of electromagnetic radiation in order to heat and cook the food. A microwave oven operates in three basic modes, which is the micro mode, grill mode, and convection mode. Micro mode is the mode which consumes the most amount of power, that is 900 watts, and the maximum cooking time which can be set is 60 minutes. Whereas grill mode, it is used to cook meat and breads, and it consumes less power compared to micro mode. Convection mode is used to heat up, or we can say preheat the food, and the cycle usually lasts from 3 to 4 minutes. Moving on to the project, the components which we used are the microcontroller from PIC family 16F877A, a 16 by 4 crystal LCD display in order to get the output, a tactile switch along with the matrix keypad in order for the user input to be delivered to the microcontroller, the timers which we used in order to count down and reset the entire microcontroller, MPLAB ID software, wherein which we have written the entire code, the XC8 compiler, which was used to compile the entire project and export an hex file, the PiximLab software, which was used to get the output of the entire project. So what is a microprocessor? A microprocessor is nothing a device which only consists of a central processing unit, and all other units such as RAM, input output ports, timer, serial COM port, everything is connected to the processor externally. Whereas a microcontroller is a system wherein which the processing unit, RAM, ROM, input output ports, the timers, and the communication ports are integrated on a single chip, and no other peripherals need to be connected externally, just like a microprocessor. A matrix keypad is consisting of rows and columns and is basically used to take the user input and feed it to the microcontroller. So for instance here, when we press the key 4, the Y1 row and the X1 column get activated, and that is how it is determined that the key press was detected. This information signal is then sent out to the microcontroller, which is then decoded and it realizes the input that has been given by the user. Moving on to the crystal display. So this is nothing but a 16 by 2 crystal LCD display and is used to display the output of the project. It operates in usually two modes, that is 4-bit mode and 8-bit mode. The PiximLab architecture is where we get to know the basic block diagrams and the integral components of the microcontroller, wherein which buses for GPIO, for I2C protocol along with EEPROM. The ADC is a unidirectional bus. It consists of a RS-232 compatible port. It consists of a unidirectional LED output. The matrix keypad connected consists of bidirectional buses along with the LCD. Interrupts are of two types, usually hardware and software. The hardware interrupts can be further classified as non-maskable and maskable, whereas the maskable can be further categorized into external interrupts and internal interrupts. It usually depends upon the peripheral that is generating the particular interrupt. Whenever an interrupt occurs, the ISR is called, wherein the ISR is nothing but an interrupt service routine which is used to handle the interrupt. Timers. Timers are an integral part of the entire embedded system, wherein which they are used to determine the count of the entire operation. Here, as we can see, a oscillator frequency and an external clock are given to the clock select chip, and the output is then fed to a prescaler with 6-bit or 8-bit. Then it is provided to a gate, and then it is the output of the timer is given to a counter, wherein which the count is incremented up to a particular value, and after the value has been reached, the counter overflows, and that is how an interrupt is generated. Let's take a look at the simulation now. These are the different modes that have been defined in the code. As we can see, the build is successful for the project.